Hi everyone. In the last video, we simulated this circuit. What is it? Yeah, we simulated this circuit using Simulink, and we've created a version of this 12-volt pulse using a pulse generator controlling a switch. Now, between the time I made the last video, I came across a particular problem with involving that technique of using a pulse generator to control a switch to create a voltage pulse. And that problem was that whenever you have your voltage dropping to zero, that's the equivalent of a short circuit, not an open circuit. So that means if we truly wanted to use that implementation, we would have something like would probably have something like a switch. We probably have two switches. So when the pulse is at zero, what will happen is that the switch connected to the battery will go off, so that it will be opened, but there will also be another switch connected in parallel. That switch will be the opposite of the input. So if the switch connected to the battery is closed, that will be open, and if that's connected to the battery is closed, if it is opened, then that will be closed. So that's the way to simulate a true voltage pulse using that methodology. Albeit it's not perfect, so in the period between the last video and now, I did a little bit of digging, and I found this component here, that actually generates a pulse. So whenever you're dealing with pulse voltages or current pulses, just search for your pulse voltage source block. It's in Simulink electrical. So yeah, so you click on that and you use that instead. It simplifies the whole procedure. It simplifies the whole process. So you just pick your starting voltage, then the amount of time it takes to get to your final voltage, then you select a value for your final voltage, then the duration of that final voltage before it drops back down to zero. So that is, so using this component, let's simulate that original circuit. Remember, we have a 60 ohm resistor, two 60 ohm resistors, a 12-volt voltage source lasting for 2 seconds, and a 3 ohms 3 Henry inductor, and a 1/27 farad capacitor. So this is our pulse voltage source. So as you can see, I've already set it. The initial value is 0, the pulse value, that's the maximum value, is 12. The pulse delay, that's the delay from the origin. I set that to 0 because we want it to start immediately. The pulse rise time, this is probably advised to not change this and change this, because for obvious reasons it's advisable not to change any of these values, the pulse hold time and rise time. Well, over here you can change the pulse width. The width is 2 seconds because the pulse lasts for 2 seconds in the question, and the pulse period, that's the total period of time for which the pulse is acting, is 4 seconds. So, which is the total time for our simulation. So let's run this and we'll see that we'll get something similar to what we got before. In fact, the same as what we got before. Yeah. So this is consistent with what we got before. Even though before we weren't using an exactly standard way of simulating a voltage pulse, but here we're using the standard method, the standard block, that's your pulse voltage block, to simulate the voltage source. And that is, so whenever you do have a pulse voltage, it's easier, it's more convenient to just use this block instead of using a PS to Simulink converter, then a switch, then a pulse generator. That's a little bit too stressful. Instead of using all three components, in fact, in the end, if you truly want to simulate using that method, you have to use 6 components, because you have to duplicate the circuit and add an extra NOT gate, so that's 7 elements. So instead of using that, you can just use a pulse generator, a pulse voltage source. So there will also be a pulse current source, but we are not doing that for this video, so that's that. Okay, so here we're going to be just simulating this circuit. So we have it up here, we have all the components we're going to need. So since we are going to be graphing the current, what we're going to use is an a current sensor. And your current sensor works in the same way your ammeter works. So you connect your ammeter in series with your branch. So you connect it in series with in a branch in your circuit to measure the current across that branch, or flowing in that branch rather. So we have all our components. We have a resistor, we have an inductor here, we have a capacitor, we have our standard solver configuration, we also have our electrical reference, we have our oscilloscope, our PS to Simulink converter. So let's start connecting. Connect this to this, connect this to this, this to this, this to this. It's advised that whenever you're simulating circuits, especially in a test, it's advised that you probably, first thing you do is to get all the components you think you need, so get them all out, so you don't have to be opening the library browser and searching voltage source, current source. So that's that. So we've connected that. Let's connect this directly. We connect our electrical reference, connect our solver configuration, and finally it's time for us to modify the parameters. So going to our pulse voltage, remember our initial voltage is 0. So let me just bring this over here so you can see. So you're starting off at 0, you're jumping directly to 12. So this is your final voltage, this is your V2 in that column. So your V1 is 0, V2 is the final voltage, that's 12. Use the delay if you want to shift the pulse this direction, you want to shift it to the left or to the right, so use the delay. Okay, so that's what we have there. And the pulse width, we said it's going to be 2. Pulse width is 2, and our period is 4 seconds. 4 seconds, as stated in the question, from 0 to 4 seconds. Actually, it was stated in this question, from t less than 0 less than t less than 4, so 0 to 4 seconds, that's our interval. So that's that. So the auto applies and we close, just saving this. Okay, so what next? We have our, okay, let's push this back here. We have our 5 ohm resistor, a 1 microfarad capacitor, and a 2 Henry inductor. So let's go here. Let's change this to 2. Come here. almost is 1 divided by 1000. There. And we're done. Okay, this should be 5. I think I'll change that to 5. This is 5. It's 5. Sorry. 5. This is 5. So that's that. Okay. So I guess now we're ready to simulate. We fixed in all the parameters. So let's save. I'll run the simulation. Okay, simulation is done. Let's look at our scope. Interesting values. But it does closely follow. I wonder why we have this point here, but if you ignore the points, it follows that pattern exactly, precisely follows this pattern that we're expecting. This, yeah, follows that exactly. So yeah, that is correct. Yeah. So I think it automatically added markers, and I'm not sure why, because it didn't add mark. None. Sorry. Yeah, that was it. Okay, apply. So it added markers. So we didn't want it to have markers. So yeah, this is it. So it's exactly what we were expecting here. So again, a final word. Whenever you run into errors in your simulation, always look at the errors, like pay very close attention to those errors. There are some errors that have sort of like links that you can click on them. By the time you click on them, they will direct you to the offending connection or the offending block. I think it will highlight it in red, so it will tell you, oh, this particular part of your circuit is what's causing the problem, or this part, or this part. So that is very helpful and very useful when you are debugging your circuits and your simulations. So I think the key takeaway from this video is, instead of going through with the technique used in the previous video to simulate a pulse voltage, just search, whenever you're dealing with a pulse voltage source, just search for pulse voltage source and use that instead. So it's a single block, it's way easier. You only have to specify a few values. It's way simpler. You don't have to be thinking about, oh, pulse duration, 5% of the total duration, and things like that. You don't have to be thinking about that. So this is the way to go. This is the way to go. So I hope you found this video helpful. If you liked it, please give a thumbs up, like, share, comment, subscribe, and we'll see you in the next one.